Dear students, we will discuss about the handshaking lemma of a graph theory. That is the first theorem of the graph theory. In this, the statement says, for any graph G with size Q and order P is summation I is equal to 1 to P d of Vi is equal to 2Q. Or they may give you the statement as sum of the degrees of all vertices is twice the number of edges. So in the graph G, Q refers to the number of edges and P refers to the number of vertices of a graph. So if I want to draw a graph here, observe now, if suppose I had took one line, U is one vertex and V is one vertex. So this side which joins U and V is called an edge. So now the degree of U is 1, degree of V is also 1, therefore 1 plus 1 will become 2. So it will be equal to, here only one edge is there, so 2 into 1, that will be equal to 2. That is how we will try to prove the theorem. So now let us go for the proof here. Each edge, since it has two end vertices, contributes precisely 2 to the sum of the degrees. That is, when the degrees of the vertices are summed, each edge is counted twice. So note that even a loop contributes 2 although the two ends are identical. So this is called the handshaking lemma of the graph theory and the first proof of the graph theory. Let us go with the next theorem of the graph theory. In any graph G, there is an even number of odd vertices. So this will be a corollary to the previous theorem, that is a handshaking lemma. That is, there is an even number of odd vertices. Let G be a graph of order P and size Q. Means the number of vertices will be P and the number of edges will be Q. Then by handshaking lemma, we have summation I is equal to 1 to P d of Vi, that is the sum of all the degrees of each vertices will be equal to 2 times the number of edges. So now what we will do here, we know that there are P number of vertices. Out of P, we will take, there will be K number of odd vertices and the remaining are all even degree vertices. So now we have taken, there will be K number of odd vertices and from K plus 1 to P, we have even degree vertices. So that I can split now summation I is equal to 1 to K degree of Vi. These are all odd vertices. From K plus 1 to P, we have even number of vertices. So sum of odd vertices plus sum of even vertices will be equal to summation I is equal to 1 to P d of Vi. This must be equal to 2Q by handshaking lemma. So where V1 to Vk are odd and the vertices Vk plus 1 to Vp are even. So now here this will be now sum of all the even terms. This is also even and 2Q is also even. So we will transfer this term to the other side. Then it will become summation I is equal to 1 to K d of Vi is equal to 2Q minus summation I is equal to K plus 1 to P d of Vi. Right hand side here 2Q minus an even number, that will be again an even number. So when the right hand side is even the left hand side also must be equal to even. Therefore now we can write this as summation I is equal to K1 to K d of Vi is also even. That is, sum of odd degrees is even, hence there are even number of odd vertices. This is about the proof of the corollary to handshaking lemma.